Okay, here's a comparator circuit that you can build yourself and use it to compare two signals and get an output. This is based on a discrete differential amplifier biased in such a way to produce on input any input change above or below zero can be detected, and the output would be between the positive power supply and ground. Now, this section here, you can connect it to another inverting amplifier and get the full supply voltage, which is plus or minus VCC, about 30 volts. You can get the full plus or minus 15 volt output if you want to do that. But anyway, regardless, this is a discrete comparator circuit that helps you to compare voltages at the input, sorry. That's a symbol of a comparator, but you just have to do this. Looks like an op-amp, but that's an comparator, and this is made of a discrete comparator. Okay, right now I'm inputting a 300 millivolt sine, peak-to-peak sine wave, and here's the output. Here's the circuit is built here for your information. I'm using dual matched NPN transistors for this. That they are KC, made by Tesla Semiconductors from the Eastern Bloc. They're dual matched NPN transistors, and they come in this metal can packages, as you can see here. And my power supply voltage is plus or minus 15 volts. Everything is biased properly. And here's our input signal, and it's being compared with ground. The moment it goes above zero, we get an output that's negative, or an output that's zero, because again, this output will be only a reference to ground. This point can swing to VCC or 0 volts, right? Because the moment this transistor saturates, this will go to VCC. The moment this transistor gets cut off, because the input here is way above, the 0 point or the 0 volts here, then this transistor will cut off, and then we'll get just 0 volts output here. Now, like I said, if you want a full plus or minus 15 output, then you would have to follow this by an inverting amplifier, which is basically a common emitter amplifier, and the output will be taken from the collector of that common emitter amplifier. Regardless, this is how it's arranged right now, but the polarity is reversed here, because the input is put here, and I'm taking it off of here, right? So this is the correct, but right now I'm actually reading it. I'm inputting it on this side here. I'm inputting it on this side, so the output will be inverted, and that's how you can see it. The moment it goes above zero, it goes below zero. The output goes to zero. The moment it goes below zero, the 0 point for this channel, you can see, is right in the middle. So the moment the sine wave goes below zero, then the output is positive, as you can see. Now, like I said, this circuit doesn't show it wired properly. I can switch it and show you, if you want to see the non-inverted output. But I'm inputting the signal is being input through a capacitor here, exactly like this. And this is just grounded, and then the output is an inverted output. So in fact, in here, this would be the positive side, this would be the negative side. So it would be like that, right? So that's the correct representation. And the reference ground for channel 1, which is a square wave output, that's our comparator output. You can see it's right way down here. I'm triggering from it. Yeah, so just a quick video showing you how to build a comparator yourself, right? You can build a comparator using discrete transistors and diodes and resistors and get a decent circuit that can compare all sorts of signals. All right, bye-bye. Take care.